Today we are going to learn about logarithms, okay? We're going to be looking at logarithmic functions. We call them log for short. Over there on the board, I have the new graph added, the logarithmic graph. We also have it here on your paper and on the board. This is the parent function for a log. Okay, so this is the type of graph we're going to be looking at for this part. Okay, so an asymptote is a line that the graph never touches. And guys, logs are different from exponentials because the asymptote for a log is always going to be vertical. Okay, that's opposite from exponentials. What were the asymptotes for exponentials? They were horizontal. Okay, so guys, on your paper, just up at the top somewhere, for exponentials, everyone write EXP for exponential. Use a capital E. This is how I like to remember it. It's horizontal. Okay, today we are doing logs. So at the top of your paper, put LOG for log, and your asymptote will always be vertical. So let's look at our very first example. We have the parent function, and I'm going to draw the asymptote for you. The asymptote is vertical, and it is right here. Everyone draw the asymptote. Everyone draw the asymptote for this one as well. I drew a vertical line. Guys, the asymptote that I just drew, what axis does it cross? Yes, it crossed the x-axis. So guys, for logs, your asymptote equation will be x equals now. Everyone put x equals for the asymptote. Now, our first log, where does it cross the x-axis? At 0. For the second one, where does it cross the x-axis? And before you answer, I want you to stop, think, and look at the graph. Thank you, 2. Look at it. This is 2, 4, 6, 8, 10. That's why I wanted y'all to look at it first. So it is not at 1, it is at 2. Now, guys, looking at the equation for number 2, I want you guys to notice that it'll always be the inside number. The opposite of the inside number will be the asymptote for a log. Okay? We'll see that as we do more examples. Okay, so let's look at the attributes here. I have an asymptote in my first graph. Does it cross the y-axis? Do I have a y-intercept? Why do I not have a y-intercept here? Because it doesn't touch this line. So I'm going to put none for y-intercept. Where does it cross the x-axis? 1. So that's 1, 0. Now, guys, my domain is different from when it was an exponential. Where's the left side of my graph? Where's the left side? 0. And it goes to infinity. My range, it goes forever down and forever up. So my range is all real numbers. That's going to be for every log. No, the domain is not all real numbers. The domain is 0 to infinity. So guys, let's look at example 2. Example 2. Do I have an x-intercept? Does my graph touch it? No. I do not have a y-intercept. Put none for y-intercept. It does not touch the y-intercept or y-axis. Does it touch the x-intercept or the x-axis? Where? Okay, so remember guys, this is going by 2s. So this is 2, 4, 6, 8, 10. Where is it touching the x-axis? Okay, I'll put 2.3. It cannot be 2. Why can't it be 2? Yes, because it has an asymptote at 2. Okay, let's do the domain. Where is the left side of my graph at? At 2. And then it goes off to infinity. Oh, this wants set notation. So guys, we're going to do it in set notation. So we're going to put x with the bar. X has to be greater than 2. It starts at 2 and it goes off to the right. So we have to be greater than 2. The range. Let's look at this graph again. Let me erase all this extra stuff. This is our graph. It goes forever down and forever up. It will always be all real numbers. All right, guys, looking at the equation, how did this graph transform? What did the -2 do? It went to the right 2. Guys, that is why my asymptote is at 2. Because it went to the right. What does this +1 do? Up 1. This number does nothing to your graph. It does do something, but it's not going to affect your asymptote or your domain in range. Okay? So let's do a quick recap. Actually, I'm going to do an example with you before we do a recap. Let's try, let's do number 5. Okay, what are the transformations, guys? Good, write that down. Left 2, up 1. Okay, my y-intercept is right here. Where is that? Y'all can give an estimate. Okay, I'll take any of those. So you said 1.7, 1.8, I'll take any of those. Where is my x-intercept? Negative what? Okay, I'll take it. It's between -1 and -2. All right, now let's talk about the asymptote. Is my asymptote horizontal or vertical? Yes, guys, we are doing logs today. Logs have vertical asymptotes. So here is your vertical asymptote. I cross the x-axis where? At -2. So that is your asymptote. Guys, a reminder. Let's look at the equation up here. It is always the opposite of this number. So if you go to the left 2, that means your asymptote is at -2. You guys see what I'm talking about? Okay. Now let's talk about the domain. Everything is to the right of -2. So everything is bigger than -2. And what is your range? Yep, I'm going to put -infinity to infinity this time. All right, let's try number 6. You guys notice there's a negative in the front this time? Let's see if it affects your domain and range. Okay, so I have a negative in the front. What does that do? Yep, it reflects over the x-axis. It went to the what? It went to the right 3. Guys, if it went to the right 3, where is your asymptote? At 3. Because it went to the right. And then it has an up 5. Okay, now notice. Let me show you that your asymptote is at 3. Guys, where is this? This is 2. This is 4. This is 6. This is 8. And this one is 10. It went by 2s. So guys, as you're doing today's practice, make sure you pay attention to see what you're going by. So notice my asymptote is right here between 2 and 4. So your asymptote is at 3. Okay, that matches my equation. It went to the right 3. Okay, what is my domain? Yep, x is greater than 3. It's going to the right, so it's going to the big numbers. And what is my range? All real numbers. This time I'm going to write it like this, negative infinity to infinity. This is an inequality form. So guys, make sure you know the different forms. Do you guys remember what this one is? Interval. Guys, just label it because on the practice, it will want each type. This is interval and this is inequality. Okay, x-intercept. It's not shown here. It does have one, it's just not shown. So I'm just going to put not shown. And the reason why you know that it's not shown is, guys, this is going to go down. This is going down. So it's slowly going down. It's eventually going to cross the x-axis. We just can't see it. Okay? Will this part ever go past this line? No, so it's never going to touch the y-axis. So I'm going to put none. Do you guys see the difference between none and not shown? Okay, this is eventually going down. It will eventually cross the x-axis. But this, we can't go past this line because this is the asymptote. So we'll never touch the y-axis. So y-intercept is none. All right, so guys, did having a negative in the front change your domain? This one still had a greater than sign. Both of these examples on the board have greater than signs for the domain. So did it change? No. So guys, this will always be your domain for logs. We're going to put greater than symbols, at least in this class.
It's not going to be less than?
Only it'll be a less than if you have log with a negative on the inside, but we're not doing that. Because if it's on the inside, that means it reflected across the y-axis would be facing like that. We're not doing that though. Okay?
So for the domain, it will always be greater.
Yeah. All right, so let's look at things without a graph. So guys, what is my asymptote? Exactly. You have to look and see if it moved to the left or to the right. Here it went to the right 4. So your asymptote is at 4. Your domain is going to be everything is greater than 4. So I'm going to put 4 to infinity. Or you can write it as this, y is greater than 4. Do it both ways, guys, so you can get familiar with it. This is interval form. This is inequality form. And if you did it in set, it'd be like this. Oh, sorry. It is supposed to be an X because we're doing domain. Make sure you have X's there. Thank you, guys. All right, now let's do the range. What's the range always going to be? All real numbers. All right, so that's number 7. What about number 8? Yep, your asymptote is x equals -3 because it went to the left 3. So now it's at -3. It's basically opposite of what's inside. So your domain will be x is greater than -3. And your range is all real numbers. Okay, number 9. Guys, when you see ln, it's no different. Sometimes you'll see ln, sometimes you'll see log. Okay, just treat them the same. All right, so did it go left or right? Nope, so what's my asymptote if it didn't move left or right? 0. And that means your domain is just everything's going to be bigger than 0. Uh-oh, I wrote this wrong. X is greater than 0. And then your range. All real numbers. Negative infinity to infinity. Okay, this one. Did we move left or right? Okay, it's going to be exactly like number 9. So let's just summarize real quick what we learned. Let's talk about the differences between a log and an exponential. How about we do that real quick? Does everyone have this written down? Can I erase it? Okay. Let's just go over, let's just recap. Okay, let's recap. For exponentials, what do you know about the asymptote for exponentials?
Y equals like
Yes, it's horizontal, good. And it'll always be a y equals. What about for logs? It's vertical, and what's the equation? X equals. What is always all real numbers for exponentials? The domain. The domain is always all real numbers. What is all real numbers for logs? The range, good. Please write down the differences. Maybe on the very front of your packet, please write down what the differences are. As long as you have this memorized, you're gold. Yep.
This was, you better not be lying.
Okay, so guys, these are the end of the notes. You guys are doing the practice.